So thank you very much. Now there's me, and I will try to keep myself to time. So hi, I'm Ceri, President of CO2 GeoNet and Principal Geophysicist at the British Geological Survey. So I thought I would talk a little bit positively about the benefits of open data. I may be preaching to the choir here, but I'm hoping that perhaps you will take some of these messages home to your governments, your regulators, and explain to them why we need these data. So, the aims of open data are to remove barriers to access, increase use, and facilitate innovation. If we look at the EU directive on data and the reuse of public information, the aim is to foster economic growth, help address societal concerns. It's an asset for development of new technology and innovation, and to foster citizen participation. So I also like some of these quotes around data is the 21st century's new raw material. And I think it's wonderful to have the raw data available so that we can use this and a way to really enhance what we do and to keep the value of the data that we have. And also, of course, the metadata, because I have seen some of the stores where you have lots of boxes, and if you don't know what's in those boxes, you're not going to find them. So metadata is also important, the data about the data. And also to note that geoscience data are critical to the advancement of any society. So this is a BGS paper. I might be a little bit biased, but it's releasing the data as open is highly effective to increase access to the data. It creates insights, leads to downstream benefits, and it also increases accountability and transparency. And I would also note that open is not necessarily free. We perhaps should make this distinction because data holders will often do this. So I wanted to think about what data we actually need. Some time ago, somebody from one of the Asia Pacific countries asked me about what's the biggest mistake people make with assessing their storage opportunities. And I said, we get to static capacity and we stop. We think that the job is done, but actually it's not. So we are looking for a way to communicate what we need, how this is the data, how we need the data, and what data we need at every stage. So this paper on storage readiness levels, I've put the link you'll be able to access from my slides. This talks about how we move through from a first pass assessment all the way through to injection. So I think what's important to note as well is that this sits alongside the SRMS. So the idea was to give a bit more granularity to the early stages. So SRMS is really when we get into the higher storage readiness levels. And what we wanted to do was to think about the journey before then. So it's based on learnings from Norway, the Netherlands, and the UK, and it's looking at assessment of regional geology. So it's a way to understand the progress towards regulatory requirements for injection and storage and planning the site as part of a commercial CO2 storage project. So we go through SRL1, which is kind of the first pass assessment. Do you have any rocks that might be suitable? We go through to 2 and 3, which is looking at our theoretical capacity. Is it actually there? Do we think we can store? And we start to get a little bit more data. So it's worth noting for the Atlas that kind of SRL 2 and 3 is great because this is kind of what we're expecting on a regional basis. This is what we need to know overall. And I would also say as a kind of general rule of thumb, we end up with SRL2 for saline aquifers because we don't have so much data, and SRL3 for oil and gas fields because we've got a lot more data. So after we've done this kind of regional assessment up to 3, we start going to storage readiness level 4, validated by desktop studies. So there we're looking in a lot more detail. And this is where the geoscientists really get excited. And we start to talk about deposition, we start to talk about injectivity, we start to talk about porosity permeability. And as a geoscientist, I have to say, don't let the mathematicians do the assessing, please. They'll just do it based on probability. We want to do this based on the geology and our understanding of the subsurface and how environments behave. But I would also encourage you to go to some of the landscapes for example, I went on a field trip to Utah and I looked at these gigantic canyons and all these piles of scree at the bottom. And I thought, can you imagine looking at this if this suddenly got filled in on a seismic section? I'm just going to go crazy. This is a mad landscape. So yes, this is where the geoscientists start to get excited. Then we start moving forward into the higher storage readiness levels. And this is more where we know a lot more. This is kind of where it gets handed over to the companies because they will have their own detailed risk reduction processes, and they will go through the sites and they will look at them with detailed analysis. In 5, they might even be collecting new data. They might drill an exploration well to check that the rocks are exactly what we think they're going to be. They're going to do some detailed analysis, so they'll have all the technical data required analysed, and the risks will be reduced to an acceptable level. When we start moving on to 6, we've got the storage integrated into an acceptable storage concepts. We're starting to really think about, we've got the customers, we've got the store, we can see how they link together. When we get to 7, we're getting to the really detailed planning, and here the engineers get involved. We've got front-end engineering studies. We've completed the permit. There will be thousands of pages of documents by this stage if we're looking at a storage site. So, I mean, this is one of my arguments for why I like the fact that there's a lower limit at which point you don't have to do all this paperwork, because as a geological surveyor, I kind of looked at the thousands and thousands of pages of information required for a storage permit for a commercial project. I thought, wow, I'm glad I don't have to do that if I just want to inject a few tons of CO2 to see what happens for my little onshore site. So then we head into the more advanced stages. We get permit ready or permitted, and then we move into the really exciting commissioning and injection. And that's the thing. As a scientist, we kind of know when it's proven it's real. So I get asked, why do you say in theory such a lot? Because I'm a scientist. I'm telling you what the data tells me. And I would love to give you absolute certainty, but I can't do that until you've actually tested it. I mean, ask me if we will see the sunrise tomorrow. I can't guarantee it for you. I'm pretty confident, but I can't guarantee it because it hasn't happened yet. And that's why we need to communicate this journey from the first pass assessment all the way through to actually using a storage site. So a little bit about what data we actually need for this atlas. So, I mean, at storage readiness level 1, we're probably just looking at geologic maps. Yep, tick, we've got some geology, might be suitable. Then we start to do some more systematic assessments. And we start to screen and rank the sites based on the information that we have, based on geological, technical, economic, geographical criteria. So when Adrian was talking earlier about the North Sea, I smiled because it's incredible the pinch points that you have. You look at this great big ocean, you go, hey, tons of space. But actually, by the time you've worked out where you can actually get from on to offshore, there's a lot of pinch points. So where the fish breeding grounds, do not mess with the fishermen. You will not win. Where the unexploded ordnance that the Ministry of Defence will tell you is there, but where all of the other environmental constraints, beware where the cliffs are slowly eroding into the sea because you don't really want to put your pipeline there. So the actual areas where we go from our onshore sources to our offshore storage is quite limited. And thinking about all of these interactions is great fun. And when we're screening and ranking these sites from the hydrocarbon fields, we'll have seismic and well data, information on CO2 source locations, storage formations, geological faults, lots of data on the wells. And so I thought I would just kind of say just a little bit about our capacity assessments. Now, for a theoretical one, basically we're saying what's the volume of the trap and what's the efficiency factor. And Owen already gave us a very clear physics view on this is the storage space you got. Now, I think if you've taken some fluids out, you might have a little bit more because you've made some space. But basically, it takes a lot of data to go into this very simple calculation. So we're talking storage readiness level 2 or 3 here. And already we've got well completion logs, interpreted seismic, core plugs, geophysical well logs. We've got lots of geological assessment. We've got an understanding of how the rocks got there. So already just to do this really simple calculation, there's a lot of work gone in. And then when we get to site characterization, there's even more. You can see the fonts getting smaller as we need even more data. And we start to think at storage readiness level 4, we're really thinking about dynamic flow simulations. So we've got like a static geological model, and that tells us what the rocks look like. And then we've got the dynamic flow simulation that tells us how the fluids are going to move through. And both of these take huge amounts of work. Now, when we've got an oil or gas field, we've got some idea about how the fluids flow through because we've already seen them come out. So we've got an idea about how the fluids might go back in. When it's a saline aquifer, perhaps we have a bit more uncertainty. So I thought I would ask my CO2 GeoNet friends. So in terms of seismic and well data availability, what's the CO2 GeoNet perspective? So it was actually a very positive response. So we had good data availability in 9 countries, some seismic and well data in another 9 countries, and limited data availability in 7 countries. And I'm going to leave it to my colleague Heike to talk about some of the issues with that. So I thought this is positive. We do have at least some data for our atlas, and as Paula showed us, although we're at low storage readiness levels, you can see that we are starting to fill in the blank spots on the map. We are starting to see these improvements, and we hope that with the Net Zero Industry Act coming out, that even more data will be available. So we asked, and there were some limits on how you could use the data. So a lot of countries did have a national data portal, usually for older data. So I think the UK, Netherlands, France, it tends to be data that's 10 years old. So new data is being released all the time from fields that are being decommissioned or older data. Some of the data could be purchased in some countries. Some data was available, but you can't publish it, or there was some data on request. I do apologise, that's gone a bit, colour's a little bit faint. But nonetheless, there was a route to get data in most of the countries, and that was really good news. So even if you have to pay for it, even if you have to go and look at it on paper and translate it from a foreign language, at least you know there is some route to get the data. And then I thought, well, here's the fun bit. So in those countries where you do have data available and you've started to do your assessments, what do you need to advance the storage readiness level of the identified stored? And out of this, 18 of the 28 comments were about, we need more data. Now, this ranged from collating the data together so it's easy to get at, collecting new seismic or appraisal wells, maybe some injection tests, better understanding of competitive use of the subsurface. So it ranged all the way from kind of we need the basic data all the way up to we need the really fancy stuff that the oil companies store in their lovely reports. And we also, of course, in some places, we reflected the regulations. So CO2 storage is banned. So what does that mean in terms of the Net Zero Industry Act? Or some clarification on the existing regulations. And also, of course, comments on funding and collaboration. So, for example, demonstrating strong political will through targeted incentives and support, and effective collaboration between government institutions and scientific researchers, research funding, improvement to the business case of projects. And I think that effective collaboration brings together very nicely that message of trust that we've seen through the rest of the forum. So we asked Eurogeo surveys members as well as CO2 GeoNet, and we asked for their help. When the Net Zero Industry Act comes out, when we see these data, what do you think is going to happen? Who's going to release the data? Is it already clear? So in a lot of countries, we had ministerial or regulatory authority release the data, often with support from the Geological Survey. In some countries, the Geological Survey hosts this kind of data, seismic and well data already, so they expect this to continue. There are a few places that were awaiting some decisions on what data. Should we shorten the time length? So perhaps we'll get data that's 5 years old instead of 10 years. And other places were awaiting ministerial decisions to confirm exactly how the data would be released or what data would be released. And a few countries where the CO2 storage was banned or it was unknown because it's outside of the EU. And I thought I would give a quick example here. So this is the UK data. So I will say that we do have open data in the UK. We benefit from this hugely. But it's not that simple to find. So we do have a national data repository, yes, but we have more than one option here. So in the offshore, and for some reason in the UK, the offshore and the onshore are dealt with quite differently, separate reports. Some of the same geology has different names just to make things really fun. So in the UK data example, we have offshore seismic and well data. Some of it's downloadable, which is really good. Some of it you can purchase. Some of it, if you're working with a company, they will very kindly give you access to all of their 3D data, and then you're very, very happy. And we also have, of course, a wonderful example here done by BGS, and I'm not biased at all, of the offshore well stratigraphy tops. And that's kind of a really nice starting point. So for most of the wells in the North Sea, we've assessed where the stratigraphy tops are, and that's kind of really useful when you're just doing a starting database. We also have onshore seismic data for purchase and onshore wells for viewing or download. So even though we've got open data, not everything is there. And it's different for on and offshore. So we asked all of our CO2 GeoNet members, please can you tell us where your national data repositories are? And you'd think it'd be kind of uniform, but it's not. It's a staggering range of approaches. There's different websites. But it's fantastic to see that, yes, people can get at their national data. And this is the value of having an association like CO2 GeoNet, because we have that expertise, that in-country knowledge. And I can say to you, yep, data is good here. Other places I can go and the national member will say, well, it looks like the data is fairly good, but actually I would be a little bit cautious here. So it's really good. You need that on the ground experience and expertise in country. So I also thought I would talk about national CO2 storage atlases. So I found the ones that I could. If I've missed, please, please, please send me links because I love to have more storage atlases to look at. So, I mean, they quote some of the benefits here. So Norway said the aim of their atlas was to identify safe and effective storage. For the UK example, the idea was to provide a living user-friendly research tool to enable cost-effective access to data to facilitate planning. So we can kind of see the benefits of open data. We can see the benefits of putting this out there. And it's great to have these interactive maps. And they're really positive. And it helps build confidence because the data's there. There's a nice atlas you can have a look at. And it helps build confidence that, yes, there is some storage capacity here that you can then look at in more detail. But even so, we're still only looking at the lower storage readiness levels just to kind of whet the appetite of all those storage developer companies. I thought for fun, I would also look at information on storage licenses and sites, and you would be surprised how challenging it could be to find basic data. So even for the Sleipner site, which is incredibly open, shares loads of their data, I ended up emailing to ask, so when you did the seismic surveys, exactly how much CO2 had you injected at that point? Because I'd been through various papers, found as much as I could, but to have that kind of level of detail that really would then allow an analysis of the seismic and all of the, how I wanted to know how much CO2 was actually in the reservoir at that time. And that was really useful. And of course, it's Sleipner. They're incredibly responsive. They're like, oh yes, here's the data, have a look. So thank you to the Sleipner project for being so open. And I would also say that the number of storage permits and licenses, it changes. And sometimes it's a little difficult to work out because it's starting to get into the commercial contracting side of things here that I happily leave to others. So in the UK, I could track 2 storage permits. So Endurance and HyNet, as far as I can tell, have storage permits. Oh, and I should explain there's kind of a 2-step process here. So there's a licensing round where the government releases some acreage and says, hey, who wants to have a go at this? And after you've got that, you can then undertake your exploration license, you can do seismic, you can do wells, you can really work up this site. And when all the requirements are satisfied, then you get a storage permit. So now you can store CO2. So it's a 2-step process where you have the ability to look for the storage, proof it up, and then to store the CO2. Denmark, I think there is 7 exploration licenses and 4 available for tender. Norway, there's 1 exploitation license or storage permit and 12 exploration licenses plus Sleipner and Synovid. And as I said, please send me any corrections because I would be happy to receive them. It's quite tricky sometimes to figure out. Sorry? Okay. This other one. And Iceland. Okay. See? So, I mean, I wrote this last week and it's already out of date. Yeah, this is how fast it goes. And Iceland, yes, I do apologize. I completely missed Iceland off the map. I'll come and visit Iceland to apologize in person. So I also wanted to. Oh, so out of date. Completely, ignore that slide, completely past. It's a week old. So I also wanted to look at information on CCS projects. Again, it's fantastically useful to have an idea of what's out there. So the Global CCS Institute, they do their annual report to cover what's happening in the world of CCS. And they said they wanted to have releasable data and intelligence on CCS, vital to understand how we can reduce emissions and meet the Paris Agreement targets. So that was their justification for their core database, which lists out the facility data, tells you the maturity and how the storage site developer is doing, and the Clean Air Task Force, which is to make visible the vast private sector interest in deploying this technology. So I think the rationale for sharing data, for making these things available is always good. And that was just 2 examples. I'm very happy again to receive more because it's always fantastic to have more information. And of course, a shout out and thanks to Philip and his colleagues for sending these information, because this is one of the fantastic examples of open data and what you can achieve with that. So the CO2 data share, it has over 57,000 data component downloads from over 1,000 countries, from across 9,000 organizations across 90 countries. So, I mean, I think the Sleipner one was the first data set uploaded. What was it, 2020? So since then, that is how much interest there is in the data. So this is what we really need, is real injection data. We need to learn by doing. We need to actually see the real data. So it's got benefits to owners and users. So the data owners can securely publish their data. The users get free access to quality assured data. And society at large can see the boost from research and development to accelerate CCS and to build confidence and to enable reproducible results. And I should also give a note that something coming soon, some data from Svelvik and some Northern Lights geomechanical data. So this is a fantastic resource, and it allows us to produce such wonderful science having these real data. And just to mention, of course, the Sleipner project. So 28,000 components downloaded, which is fantastic. And it's just, as I said, it just shows you the interest in having real data. And with that, I will stop. And I hope that you're feeling a little bit positive that we have data, that we want to use it, that we want to produce good science and provide confidence in our storage resource. Thank you. And then since I'm already at the front, I will hand over to my colleague who will try to present a positive view on what we can do where we have these horrible data gaps. So Heike, I will hand over to you.